Good afternoon, class. We are looking at pre-calculus practice test module 1. And here's the next chapter, chapter 2, linear functions. All right, so let's look at a couple of definitions quickly. Dependent and independent variables, or an equation in variables x and y. If the value of y depends on the value of x, then y is dependent and x is the independent variable. When we have a function like this, all values of x are considered possible values of x are domain, all values of y are considered the range. So relation is defined as a set of ordered pairs. Domain is the set of all inputs or x values or independent variables for a relation. And the set of all output values or the y variables dependent would be the range. A function is a relation in which each element in the domain corresponds to exactly one element in the range. And we use a vertical line test to test it. If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph doesn't represent the function. If a vertical line cannot be drawn so that it intersects the graph at more than one point, then the graph represents a function. A function is one-to-one if each element in the range corresponds to exactly one element in the domain, and therefore it has to pass what's called a horizontal line test. If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function. In other words, the vertical line test in essence says x can't repeat for it to be a function. Now y cannot repeat for it to be a one-to-one function. And I have the difference quotient, the f of x plus h minus f of x over h, as h can't be 0, just to let you know. All right. We want to find the domain. Anytime you have a rational expression, you set the denominator equal to 0 and you exclude that, so x can't be 1/2. And so you set it equal to 0, x equals 1/2, and the domain is this, x can't be 1/2. This is the answer. Now, the way you represent that is with the inequality, or this is the interval format. The second case, 5x plus 4 must be greater than or equal to 0. And that means x is larger than or equal to negative 4/5, negative 4/5. And you can represent it with an interval format or an inequality. The last one is a quadratic function. As you know, all polynomials, the domain is all real numbers. We use negative to positive infinity. That's why, because it's a quadratic function, all polynomials have the domain, which is all real numbers. That's what. When the index, this is called the index. When it's odd, there is no restriction. It's all real numbers. In this case, we set the denominator equal to 0 and exclude that. X squared minus 1 is 0. As you know, x is plus minus 1, because you can write x squared equals 1. And now we're going to exclude those. Now, if you write this as the domain, it's fine. But in an interval format, we write it in this format. Negative infinity to negative 1 union, negative 1 to 1 union, 1 to infinity. Notice the parentheses mean we are excluding the endpoints, namely 1. Finally, this one is a linear function, and the domain is all real numbers. Remember, for all polynomials. for all polynomials. The domain is all real numbers. This is a polynomial of degree 1 or a linear function. Determine if the graph represents a function, a one-to-one function, and find the domain and range and so on. So is this a function? Yes, because it passes a vertical line test. Is this a one-to-one function? Yes, because it passes a horizontal line test. What is the domain? The domain is from 2 to 8, and 2 is not included, from 2 to 8. And the range is from here, 6 to 8, and 8 is not included. So I hope you can see that this one to this one, this would be the domain. This one to this one, this would be the range. So the next one, is this a function? Yes, it is a function because it passes a vertical line test. Is it the one-to-one function? No, because it fails the horizontal line test. For example, if I draw this one, these two have the same y coordinates. So it fails the horizontal line test. What is the domain? The domain starts with me use a different color. The domain, if you go up here and starts from here, and it is all the way to here with a hole, that would be the domain from -3 to 2, and 2 is not included. But if you look at the range, this one gives you a solid point. The top gives you a solid point. Everything in between is the range. That's why both of them, they take brackets. Both of them, they take brackets. The last one is neither a function nor a one-to-one function. It fails both the VLT as well as the HLT. The domain is this one from -4 to 0. The range, the bottom is here. The top is here. It's from 0 to 4. So I hope we can see that. I hope we have no problem with the domain and range. All right, we are given f of x equals 2x plus 1, and we want to find this, which is the difference quotient. So I'm going to remind you of the rates of change. The difference quotient, delta y over delta x, rise over run, or f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 is called the average rate of change of y with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line. That means if you have a curve and you have two pairs, you connect them and it becomes the blue line is the secant line. And later on we discuss the tangent line in actually calculus. Now, all of these are the same representation, rise over run. If you call this x sub 2 and over here x sub 1, it gives you this formula. If you call this x and a, it gives you this formula. If you call this a and b, it gives you this formula. If you go with this one, a and a plus h, it gives you this formula. Okay, so just you know, if we go with a and b, for example, it gives us this formula. Okay. If we go with a and x, gives us this formula. So they're all the same. All right, so we want to get f of x plus h minus f of x over 2, the difference quotient. So that means 2 times x plus h plus 1 minus the parenthesis 2x plus 1 over h. That's what it means. So all we have to do, distribute, simplify. So this becomes 2x, this becomes 2h plus 1 minus 2x minus 1. So distribute. Two x and negative 2x cancel each other. Positive 1 and negative 1 cancel each other. The numerator is 2h divided by h is 2, and you're done. Given the function f of x is 2x squared plus 1 and g of x is 3x minus 5, we want to find f of g of 2. So quickly, algebra of functions, f plus minus g of x means f of x plus minus g of x. F times g of x is f of x times g of x. F over g of x is f of x over g of x, but obviously g of x can't be 0. And a composite function, f of g of x is f of g of x, and g of f of x is g of f of x, and that's what we have here as far as the domain and range. So when we say f of g of 2, the very first thing we have to figure out is g of 2. We have to figure out what's g of 2 first. Let's do that. Here's the g function. Let's plug in 2. 3 times 2 minus 5. And that 6 minus 5 equals 1. So that means we want f of 1. So we want f of 1. Now plug in 1 here. 2 times 1 squared plus 1, which makes it 1 times 2 is 2, 2 and 1 is 3, because 1 squared is 1, everybody. So the answer is 3. F of g of x, or f of g, basically it means in the f function, anywhere you see x, replace it with 3x minus 1. So it becomes 2 times 3x minus 5 squared plus 1. That's the meaning of it. Now, this, again, a minus b squared is a squared, so 9 squared, minus 2 times this 2. So 3x and 5 is 15x times 2 is 30x. We have a negative sign, minus 30x, and square this becomes 25. Again, I'm reminding you of, remember we did a minus b quantity squared and a plus b quantity squared. Let me just write that for you. Okay, so this is 3x squared minus 2 times 3x times 5 minus, plus 5 squared, and that's what we have. Now you distribute the 2, you get 18x squared minus 60x plus 50, and with 1 becomes 51, and that's the final answer. All right, we're going to continue with that. We want to find g of f of x, which means instead of x, put f of x or 2x squared plus 1. Now, if I distribute, I get 6x squared plus 3. Combine it with negative 5. You get 6x squared minus 2. All right. So into the g function goes the g function, meaning replace the x with 3x minus 5. And so 9x minus 15, combine the negative 5, 9x minus 20. F of negative 2 again means to find f of negative 2 first. So into this goes negative 2. Okay, so that's what we want. F of negative 2, 2 times negative 2 squared. This one is 4 times 2, 8, and 1 becomes 9. Therefore, you're looking at f of 9. So f of 9, 2 times 9 squared, this is 81 times 2 plus 1. So 2 times 81 is 162, and 1 becomes 163. Are they odd or even? So by definition, everybody recall, a function is even when f of minus x is f of x, which means symmetry with respect to the y-axis. A function is considered odd when f of minus x is minus f of x, it is symmetric with respect to the origin. WRT, with respect to. And so we are going to evaluate each one at minus x. So for example, f of minus x. So replace the x with minus x. So when you square it, you get the same thing. X, this becomes x squared, so it's 2x squared plus 1. And since it's identical to f of x, it makes it an even function. For the g function, let's replace the x with minus x, makes it minus 3x minus 5, which is not equal to g of x. It's not equal to the opposite of that. So g of x is neither even nor odd. We want to find the average rate of change of each function on the specified interval. So basically, what was just happening, we went over that. It is asking for rise over run in essence. So in this case, we want f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, or g of x sub 2 minus g of x sub 1 over x sub 2 minus x sub 1. So this is the interval of interest. That means one of them is x sub 1, one of them is x sub 2. This is not a pair. A pair is inside the parentheses. So this means from x equals negative 1 to x equals 1. And f, or in this case, maybe you want to change it to a g. Okay. And so when you evaluate that, so you have 3 plus 3 here, and you have 1 plus 1 here, and the answer is 3. Now, in this case, from 4 to a, that means f of a minus f of 4 over a minus 4. That's the meaning of it. So plug in a, plug in 4. All right. So when we plug in a, we get 2a minus 9. When we plug in 4, we get 2 times 4 minus 9. The denominator is a minus 4. So let's simplify the numerator. 2a minus 9. And as you can see here, it's 8 minus 1 or minus 1. So this makes it plus 1. And the numerator is 2a minus 8. We can factor out the 2 from the numerator. The final answer is a minus 4. H of x is given on the interval of 2 to 2 plus h. That means f of 2 plus h minus f of 2 over 2 plus h minus 2. And of course, since this is h, we should say h. And we should evaluate it. So we have 3 times 2 plus h plus 4 minus 3 times 2 plus 4. And to simplify it, we are going to have 3 times 2 is 6, plus 4 is 10. And as you can see, 6 and 4 and negative 10 cancel each other. The numerator is only 3h. And we end up with the answer 3. All right, just reminding everybody about graphing techniques. So basically, you have the function f of x. You can move it up by c, f of x plus c. You can move it down by c, f of x minus c. We are assuming c is positive. And f of x plus c, that means move it to the left by c. And f of x minus c means move it to the right. And in this case, if c is larger than 1, we are stretching it by a factor of c, or we are shrinking it, if you will. If it's minus f of x, it will flip over, this is the y, with respect to the x-axis. It's f of minus x will flip over with respect to the y-axis. So this is the synopsis of this translation. So the following function was graphed by applying transformation to a toolkit function or essential function. Write the equation of the function that matches the graph. First and foremost, there are many graphs you got to be very comfortable with. They're called elementary functions. Okay, there are different terminologies for them: toolkit, essential, you name it, such as constant function, identity function, square function, cube, so on and so forth. So take a look. This is the constant function f of x equals b. This is the identity function f of x of y equals x. This is y equals x squared. This is the cube function, square root function, cube root function. So you should have the general idea, and there are a few more functions coming up. Another one is the V shape for the absolute value function. So y equals absolute value of x, the vertex is located at 0, 0. So when we compare the two, we notice the new vertex is located at a different location, 3, negative 2. So we write the general format as y equals a, the absolute value of x minus 3 minus 2. So we have shifted it accordingly. 3 units to the right, 3 units to the right, so minus 3. And 2 units down, so minus 2. And the reason we write the a, because we don't know if the v has changed, or has been stretched or shrunk, and we put the a to be on the safe side. And all you have to do, pick up any easy pair. Okay, for example, you can see 1, 0 here, 0, 1 here. You can plug it in. Any of those pairs, you don't have to do both. Any of those pairs will do the job. If you go with 1 and 0, that means replace the x with 1 and y with 0. This is 1 minus 3 or negative 2. Negative 2, the absolute value is positive 2. So this is negative 2. Inside the absolute value comes out as positive 2. So 2a minus 2 and a becomes 1. Replace it, and this is the final answer. And of course, as always, you want to check your work by picking up a different point. So for example, we use this point, check this point, or some other point on the graph, maybe a couple more points to check your work. The following function was graphed by applying a transformation to a toolkit function, essential function. One of those functions, we want to write the equation of a function that matches each graph. And again, we remember the basic y or f of x equals absolute is the square root of x. We remember that one. And we notice the shape is the same as that one. It has been some sort of a shift. And so as you can see here, of course, the x-intercept, which happened to be the y-intercept as well, is located at 0, 0 and has been shifted. So now it's been shifted to the location -3, -1, which means we've moved it 3 units to the left. So that means this x is +3. And then we moved it 1 unit down. That means -1. And again, we're going to put an a here because we don't know if we did the stretch or not. And so we pick some easy point and we plug in. For example, we can clearly see this point located at -2, 0, 0. So replace the x with -2, replace the y with 0, just to make sure we know what is a. So when we do that, this is 1. Square root of 1 is also 1. So a -1 is 0, and a becomes 1. And so we plug in. And as I mentioned, as always, check with some easy points. For example, I think this is 1, 1. You can check it out to see it works, and it does. All right, we're going to do the same thing here, and we notice it looks like, some sort of a shift has happened to y equals x squared. And the vertex, which was located at 0, 0, now has a different location, which is -1, 2. So with that being the case, we are using y equals x squared. And we're going to write y equals a times x minus h quantity squared plus k. Remember the general form, you can do that, or just look at the movement. It has been shifted to the left. So because this is -1, you got to write +1 here, okay? And the 2 has shifted up, +2 here. So that's because of the vertex. And all you have to do, pick up an easy point. For example, the y-intercept is located at 0, 1. The y-intercept is located at 0, 1. That means replace the x with 0, replace the y with 1. Again, always use the easy points if possible. Of course, this is 1 and square root is 1. So this basically is 1, square root is 1. So this is a +2. So a must be -1. And now if we replace it here, this would be the final answer. And I highly recommend, again, pick up another pair, something easy you can locate and check your work. Always check your work to be on the safe side. All right, I'm going to find the equation of a function that is finally graphed after the following transformation are applied to this. So first, we shifted to the right by 3 units. So x minus 3 quantity squared. Then we reflected about the x-axis. So we put the negative in front of that. And then we go down by 2 units, down by 2 units, so -2. So those are the transformations. All right, let's discuss the extrema quickly and the definitions. An absolute or global extrema or value or extrema are either maximum or minimum points on a curve. Extrema is the plural for extremum. Absolute minimum occurs at the point C if f of c is less than or equal to f of x for all x values in the domain. If you look at this graph, you see that there is no more point below that. By the way, these are peaks and valleys, so they are called local extrema. This is local mean, local max, local mean, but this one is not only local mean, it's absolute mean, because no other point is below that. Absolute max occurs if at the point C, if f of c is larger than or equal to f of x for all x values in the domain. So as you can see, local max, local mean, local max. This local max is also an absolute max. Local or relative. A local minimum is the minimum value within some open interval. Local minimum occurs at a point C in an open interval of A to B in the domain if f of C is less than or equal to f of x for all x values in the open interval. So as you can see, this is a local mean, this is a local max. A local max is the maximum value within some open interval. Local maximum occurs at the point C in an open interval of A to B in the domain if f of C is larger than or equal to f of x for all x values in the open interval. And again, local mean, local max. We also have this extreme value theorem. If f is a continuous function whose domain is a closed interval, then f has an absolute max and an absolute minimum. So we want to estimate the interval where the function is increasing or decreasing. Okay, so the function is increasing here, decreasing here, increasing here. In short, the definition of increasing, a function f is increasing on an open interval for any choice of x of 1 and x of 2 in I. X of 1 is less than 2, we have f of x of 1 less than f of x of 2. A function is decreasing on an open interval I if for any choice of x of 1 and x of 2 in I, with x of 1 less than x of 2, we have f of x of 1 larger than f of x of 2, and if nothing happens, it's a constant. The function is f is constant on an interval of I if for all choices of x in I, the value of f of x are equal. A short definition for me for the increasing part class. We remember from left to right, x gets larger. What happens to the y? The y gets larger too. From left to right, x gets larger. What happens to the y? If it gets smaller, it's decreasing. That's all there is to it. So with that being the case, we can clearly see that it is increasing here. It is increasing here, and therefore that's the answer. It's decreasing here from -3 to 3 or -2 to 3. It depends how you want to write that. In MOM, in my open math, they may use a bracket on that, but either way, the better answer would be to use parentheses. Determine any local max or minimum values. Obviously, look at those points. This is a local max. This is a local mean. So maximum occurs at this point. This one is not in the right spot. 50, when x is -3. You want to pay attention to the question, how they're asking you. Okay, they may ask you for this one, local max is equal to 50 at this pair. So see how they ask you. And for the minimum, it's here. And that takes place at x equals 3, and that's -50. Let me clean up the mess. It makes it easier to see it. So this is local max, local mean. Okay, it's easier to see it this way. Determine any absolute max or minimum values. Now, this one, again, those points, another. This one, because it ends, if it continues, there is no absolute max. If it continues, there is no absolute mean. Because there is a solid dot, it stops here. The absolute max equals to the y coordinate of this point. And at 7,150. It depends how they ask you. And this is the absolute minimum. The y coordinate seems to be -225 at x equals -8. And again, it is extremely important to notice this thing stops, doesn't continue. Sometimes they just show that it continues, sometimes they just put an arrow. We want to find the inverse function, and to do that, first and foremost, here's the process. First and foremost, we change f of x to y because it's easier to work with. Then we interchange x and y, and right here in this step, we do have the inverse. However, we don't stop, we solve for y, which means I'm going to move the 7 and I'm going to divide by 2. So this is step 1, step 2, step 3. And at this point, we give it a name f inverse. We are done. It's a good practice to check. So in order to check the composite function f of f inverse, or f inverse of is equal to x, we're going to look at quickly one of them. For example, if we look at f of f inverse of x, that means over here, we're going to replace the x with x plus 7 over 2. As you can see, these two cancel each other. We get x plus 7 minus 7, which is x, and that's a proof that they are inverse functions. Let's look at a more interesting example. We're going to replace f of x with y because it makes it easier to work with. We're going to interchange x and y. And again, in this step class, we do have the inverse function. However, we continue and solve for y, which means in order to do that, we do the cross product. Multiply these two, x times y plus 2 times x, and we equals 1 times y. Since we want to solve for y, we're going to move this one. We're going to factor the y from the right side, becomes y times 1 minus x. And we're going to divide both sides by 1 minus x. And we're going to replace the name y with f inverse of x. By the way, depends on how you move things. It's important to see these two are identical. And if somebody moved it differently in this step, we could have had minus 2x over x minus 1. So either way is fine. Now, to prove we haven't made a mistake, we look at f of f inverse or f inverse of f. In this case, we're going to look at f of f inverse, which means we're going to replace the x with either one of those. In this case, 2x over 1 minus x. And we want to see if we end up with x. We are dealing with a complex fraction. To simplify it, we multiply the top and the bottom by LCD, which is 1 minus x. So if we multiply this one by 1 minus x, gives us 2x. If I multiply this one, this fraction also gives us 2x, and then plus 2 times 1 minus x. So this times this 1 minus x goes away. This times this 1 minus x goes away. Plus 2 times this one, and you're going to work on that. So this becomes 2, and this becomes minus 2x. 2x and minus 2x cancel each other. 2x minus 2x. 2x over 2 is x. And we proved that we've come up with the correct answer. We want to verify these two are inverse of each other. That means we have to show their composite function is x. So we know f of f inverse is x, therefore we're going to show f of g is x in this example. So we want to show that f of g is x. Clearly, these two cancel each other. And cube root of x is x, and we just proved it. Now GOF, you don't have to show both, but I'm going to show you for practice both ways. GOF, and as you can see, this comes out as x minus 1 with plus 1. We prove this is also x. So you show either FOG is x or GOF. You don't have to show both. One is good enough, class. But for practice, we did both. We want to sketch the inverse of the function whose graph is shown. And to do that, just remember if A comma B belongs to F. This is red an element of, therefore B comma A is an element of its inverse if two functions are inverse of each other. So you always locate easy points. So draw a line y equals x and reflect the graph on the line. Remember, because it's symmetry with respect to y equals x. So the best course of action to do this is to look at a few points. For example, you can see that -2, -4 belongs to f of x. So make it, so f of -2 is -4. That's the meaning of it, by the way. So f inverse of -4 is -2, meaning if this belongs to f of x, then -4 -2 belongs to f inverse. That's the meaning of it. And this is the explanation in between. We locate another point. So -4 -2. So for this one, we get this one. Well, we locate another point having coordinates 0, 4. If 0, 4 belongs to f of x, then 4, 0 belongs to f inverse. And writing would be as follows. This means f of 0 is 4. And f inverse of 4 is 0. And 4, 0 belongs to f inverse. Means this point. Another point. -1, 3 belongs to f of x, then 3, -1 belongs to f inverse. Again, you may need 2 or 3 or 4 points. So that means f of -1 is 3, and that means f inverse of 3 is -1. As I said, this becomes 3 minus 1, right, belonging to f inverse. And if you locate that and you put them all together, looks like this. And this is the line. So this, draw the line and reflect the graph on the line. That means basically draw the line, and in order not to make a mistake, so draw the line and pick a few points, and we did that. And those are the points. Very straightforward, everybody. Okay. We want to sketch the graph of the function f of x and evaluate a few points and determine the domain and range. All right. It says graph y, if you will, of -x plus 1 if x is between -1 and 1. So you want to graph that, which is simply a line. If you look at this one, it's just a line, y equals -x plus 1, and you can pick up a couple of pairs and graph it. So with -1, if you plug in, because x is between -1 and 1, and it includes -1, and it doesn't go beyond that. So negative of -1 is +1, and 1 is 2. Okay. And all the way to 1, right? So if I plug in 0, I plug it into this one class, I get 1. If I want to plug in 1, at x equals 1 is equal to 2. I don't have to plug it anywhere. At x equals 1 equals 2. At x equals 1 equals 2. If I want to go with larger than 1, for example, 2, I go here and I write 2 squared, which is 4. I want to go with 3 squared, which is 9. Okay. So all you have to do, draw a few points and you have it. But let me make sure everybody understands what's going on here now. If you look at this line, this line is y equal to minus x plus 1. And this graph is y equals x squared. Again, this is not the graph. I just want to show you how you do that. So first and foremost, you draw this line, then you draw this function, and then you do your restriction. So your restriction starts, it says when x is less than or equal to -1, that means we are here, we can use this line. So at -1, it's 2. So at -1 is 2. So right here, -1 is 2. This point is -1 comma 2. What about this part? It's not part of the graph. And then at 1, what happens if you plug it in? At 1, we get 2. So at 1, we get 2. Over here, if you plug in 1, you get 0, which is not part of this graph. And for x larger than 1 is x squared. So let's locate 1. At 1, we get a hole here. Let me use a different color here. Red one. This portion of the parabola is not part of the graph. This portion of the parabola is not part of the graph. And at 1, we have 2 at 1. So this point also belongs. So, and the line, again, if you plug in 1, you get 0. That doesn't belong either. So this is what we have. Now, here's the graph. Here's the graph with the proper restriction and the domain anywhere from -1 to infinity and the range from 0 to infinity. I hope you see that. What happens as far as the domain is concerned, since this is a solid point, -1 is included to infinity. Solid point, -1 to infinity. But what happens, the range, this is not a solid point, so this doesn't belong. So all the y coordinates in the positive side, but not at 0 or below that. All right. Find the average rate of change for this case from 2 to 4. And so basically, f of b minus f of a over b minus a. So f of 4 minus f of 2 over 4 minus 2. So plug in 4 squared minus 3 times 4, and then 2 squared minus 3 times 2, and simplify. So this is 4 squared or 16 minus 12. That becomes 4 minus -2, which becomes positive 6 over 2 or 3. The second part from 4 to 4 plus h. First, we're going to plug in 4 plus h, which means 4 plus h squared minus 3 times 4 plus h and minus f of 4. You can use that or just evaluate it again. We've already done this f of 4. So this becomes 16 plus 8h plus h squared minus 12 minus 3h. And if we were to write this, this is 16 minus 12. So minus 16 plus 12, if you want to go that route. The reason I kept it as that, because I hope everybody can see that this one, this one, this one, and this one, they add up to 0. And then what remains is h squared, 8h, and 3 minus 3h, they add up to 5h. From the numerator, we can take the h out, they drop, and the final answer is h plus 5 or 5 plus h, however you want to write that, h plus 5 or 5 plus h. All right, find the value of x if a linear function goes through the following points and has the following slope. So find the slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's really the bottom line. So reminding everybody that standard form was ax plus by equals c, slope intercept form y equals mx plus b, and point slope y minus y1 equals m times x minus x sub 1. And therefore, again, vertical line x equals a, m is undefined, x intercept is a0, horizontal line y equals b, m equals 0, y intercept is at 0, b. Two lines are parallel if they have equal slopes, different y intercepts, and perpendicular if the product of their slope is -1 or one is the negative reciprocal of the other. And so with that being the case, we are looking at rise over run. And so if we were to write this, we would write m is 3, so 6 minus 2 minus 4 minus x. So the numerator is 4, and if we do the cross product, we multiply these two, and we multiply these two, we get minus 12 minus 3x equals 4. If I move the -12, the right side is 16. Division by -3 gives us the answer. Minus 16/3. Could somebody read this, please?
Consider this scenario. A town has an initial population of 75,000. It grows at a constant rate of 2,500 per year. Find the linear function that models the town's population P as a function of the year T, where T is the number of years since the model began.
Excellent. In essence, we are using y equals mx plus b. In this case, we're going to change the y to p and x to t. So there's some explanation here. P of t is the population as a function of time. M is the constant rate of growth of the function. In this case, it's 2,500 per year. T is the time elapsed in units of years, and B is the initial population, which in this case is 75,000. The linear function therefore becomes 2,500 t plus 7,500. So 2,500 is the variable value, which is the slope, and 75,000 is the initial condition, also known as in this case we would call it the y-intercept. In this case we would call it the p-intercept. All right, let's look at this last question. Monthly cost of a cellular plan depends on the number of minutes used and a flat fee. So 410 minutes, they're going to cost us $71.50. 720 minutes, it's going to cost us $118. So we want to express the cost as a linear function of the monthly minutes used, and they said, okay, use X. Now, First and foremost, we normally have X and Y, but now we're going to have X and C. Secondly, 410 minutes, the cost is $71.50. 720 minutes, the cost is $118. That's how you write it. So it's important to see which one comes first. The first one is the independent variable. So to calculate the slope, M is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But in this case, we're going to say c sub 2 minus c sub 1 over x sub 2 minus x sub 1 because we are using c instead of y. In fact, you can keep it as y and at the end change the c, change it to c. So if you can get confused as far as the variable, stick with x and y and then change it to the variable they give you. So in this case, we are going to write 118 minus 7150 over 720 minus 410. And we're going to simplify the top and the bottom, 46.5 over 310, and it becomes 3 over 20 or 0.15. Then everybody remembers y minus y1 equals m times x minus x of 1. So we're going to write, in this case, c minus one of those. Okay. If, for example, if you use this one, c minus 118 is m or 0.15 or 3 over 20 times x minus 720. So if it helps, again, like I said, you can always keep it as y. So y minus y1 equals m times x minus x of 1. All right. So what we are doing is c. So you can stick with y and change it. So when we plug in and we distribute the 3 over 20, we end up with c minus 18 is 3 over 20 times x minus 108. And we are going to move this and make it positive on the other side. And c is 3 over 20 or 0.15 x plus 10. You can use it like this or 0.15 or 0.15x plus 10. So how much will it cost if we use 687 minutes? That means replace the x with 687. And approximation, because we are dealing with money, we go with 2 decimals. Even if it gives us more, we round it accordingly. What is the meaning of the slope and the c-intercept, the y-intercept? In essence, it was mentioned. The c-intercept represents the fixed monthly cost, the flat fee charged by company, which is $10. The slope represents the change in cost per minute of call for the amount of 15 cents or $0.15 per minute. That is the meaning of the slope, everybody.